All right, we're going to take a look at homework 4. We start with the definitions of mean, median, and mode. And mean, median, and mode are three measures of central tendency. The mean is all the values the sum of all the values divided by the number of values, and it can strongly be affected by outliers. Our first question is conceptual. It's asking us for the definition. That's a perfect definition in A, so we're going to leave it just like that. Oh, I press the next button. When there's multiple parts, I need to press continue. Don't leave questions blank by doing that. Choose the correct description for median. Median is the middle value. Middle. Okay, so when we look for the median is the sum, nope. It's the most common, nope. Sum, nope. Middle value. So I see two of them that say middle value. The question is it affected by outliers or not? And the answer is no. The median is not affected by outliers. That's one of the big strong points for medians. And the last one is the mode. The mode isn't the middle. It isn't the sum. It's the most common value. So it's the number that occurs the most, which means it's not really affected by outliers because it's not looking at outliers. It's looking at whatever happens the most. So the mode is the most common, and it is not affected by outliers. Let's see. Oh, I skipped one. Number 2, what are outliers? Speaking of outliers are data points where if you have all the numbers like 3, 4, 7, 8, and then you added in the number 107. 107 is way outside of the normal. So an outlier in a data set is a value that is much higher than almost all other values or lower. So you look at A in this one, it says much higher, but it doesn't say lower. An outlier does not change the mean, median, or mode. Well, that's not true. It does, actually. An outlier in a data set is a value that's much higher or much lower, and it does affect the mean. The mean is adjusted by outliers, but the median and the mode, not really. What do we mean when we say that a distribution is symmetric? Symmetric, meaning that it has symmetry right in the middle. Give some examples of symmetric, left skewed, and right skewed. And we have 3 parts here. So the first thing is, what do we mean then when it's symmetric? Well, we do mean it's single peaked, and that its left half is a mirror image of its right half. I'm going to say, let's read them all, okay? Because this one can get a little bit tricky here. The left half is a mirror image of its right half. Its values are more spread out on the left side than the mode. I'm going to say no. We don't say it's more spread out on one side if it's symmetric. Its left half has as many data values as the right half. That's probably true. And if its values are more spread out on the right. So it's definitely not more spread out. The question is whether it's supposed to be the mirror image or have as many data values on the right and left. And so I'm going to say C. Oh no, it's just a mirror image. Look at that. Give an example of a symmetric distribution. So an example of symmetric distribution would be the height of a sample of 100 women. Is that a symmetric? The number of books read during the school year by 5th graders. The speed of cars on a road where a visible patrol car is using radar. And the weights of a sample of 500 dogs of varying breeds. Okay, so when we think about each one of those, it's really weird the way they're asking it, but it's to imagine the answers to those questions. Okay, so of those, which one would be symmetric? I would be tempted to say D, the weights of 500 dogs, or A, the heights of a sample of 100 women. The reason I like those is 1, it has a lot of people involved. 2, those are kind of continuous things. So the heights of 100 women seems like it would just be pretty balanced. There'd be a middle. But my thinking with the 100 women is that you're going to have some women, there's going to be more women that are below the mean, more extra short women than there are extra tall women. So I don't think that's going to be symmetric. But let's find out. Oh no! See, this is very difficult, as I just got two of them wrong. Give the simple example of a left skewed distribution. A left skewed distribution, choose the correct answer below now. And so this is where we're dealing with these two. Left skewed meaning the left tail is longer. Left tail is longer. So I would say, we already had heights of women we could say heights of men. We could say number of books read. When I think about the number of books read for fifth graders, I think most fifth graders read, like, let's say 8 books. And then there's going to be some that read like 100 books. You got those kids that read all the time. And so that long tail is on the right. And so I don't think it's the number of books. The weights of a sample of 500 dogs of varying breed. Well, there are some breeds that are really heavy, and there are some breeds that are light. But I think it's probably, I'm going to say that it's A. My thinking there is left skewed. Remember, we have a longer tail on the left side. So if we were to say that everybody's going about, let's say the speed limit is 65. And so if everybody's going 65, a lot of people are going to go 65 or under when they see that cop car. Not that many people are going to go above 65. Yay, I got one right. The symbol of a right skewed distribution. Right skewed, we talk about these, and I'm going to go with the fifth graders. I think there's going to be some that read a ton that's going to pull it right. Yay. All right, so I probably want to go back and fix those, but I'm going to keep moving. Decide whether the following statement makes sense or is clearly true, or does not make sense or is clearly false. In my data of 10 exam scores, the median turned out to be the score of the person who had the third highest grade. No two people got the same score. Okay, so let's think. 10 exam scores, the median is supposed to be the middle number. So if nobody got the same grade, let's just say they got 70, 75, 80, 85, 90, 92. Trying to make 10 of them here. That's 6. 94, 95, 99, and 100. Is that 10? 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. So that's 10 people there. The median is the middle number. I put them in order already. So the median should be the number in the middle. So if there's 10, it should be 1, 2, 3, 4, 5. So it should be right here. We've got 5 over here and 5 over here. And so the median of this would be 91, because it's actually right in between 90 and 92. But the question says, but the person who got the median had the third highest score. Now, if they don't tie, that doesn't seem like it makes sense to me. So I'm going to say no to that one. The median is not the sum of all the values. This does not make sense because the median should be between the 5th and 6th. That's what I believe. And then let's check it. Yay. I'd like to get a few in a row so I don't look so silly after I got like 3 wrong. Decide whether each of the following statements is true. I made a distribution of 15 apartment rents in my neighborhood. One apartment had a much higher rent than all the others, and the outlier caused the mean rent to be higher. So, does it make sense? Well, it doesn't make sense because an outlier with a large value increases the mean and the median by the same amount. That's not true. If we make this number right here a 200, it doesn't change where the median is still 91. So that's not true. The statement doesn't make sense because an outlier with large value decreases the mean. Well, that's not true. The statement makes sense because an outlier with a large value increases the mean, but does not affect the median. I like it. Yeah, increases the mean, but does not affect the median. Decide whether the following statement makes sense. The distribution of grades was left skewed, but the mean, median, and mode were all the same. Left skewed, but the mean, median, and the mode were all the same. Well, if it's not symmetric, then that doesn't make sense to me. Because if it's left skewed, then we have outliers that are pulling the mean towards the tail. The mean skews towards that tail. So I'm going to say this does not make sense because the mean and the median should lie somewhere to the left of the mode. Okay, so the other option would be that they should somewhere to the right, but it's going to pull it that way. The numbers of words defined on a randomly selected page of a dictionary are shown below. Find the mean, median, and mode. Okay, so we're going to go through how to find these. The first one is mean. How do we find them? Well, we add them all up and we divide it by the number there are. So I'm going to go ahead and do that on a calculator to make my life easier. So I'm pulling up my calculator. And I'm going to start typing 32 plus, let's use the big calculator here, 67 plus 62 plus 70 plus 33 plus 66 plus 77 plus 40 plus 74 plus 58. All right, I got 579. What I want to do is I want to take that number and divide by the number there are. So how many numbers were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different numbers. So I'm going to divide that by 10. And I got 57.9. So I'm going to go for it as the mean is 57.9. Fantastic. Next thing it says, what's the median? Now the median, I don't need to do the math here. I need to put them in order. So I'm going to go ahead and pull up my scratch paper here. Let's put them in order. We have 32, 67. Well, I got to try to be better than this. 32 is the smallest, and then we have 33. And then we have 40. And then it looks like 58. And the fifth number is, looks like 62. Then 66, 67, 70, 74, and 77. So let me see if I got them all. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Again, there's 10, so we're going to go ahead and say I need 5 on the bottom half and 5 on the top half. And the median is going to be right in between 62 and 66. So it's not 62 or 66. It's between those two. So I'm going to add those up and divide by 2 to figure out what the mean is. So 62 plus 66 is 128. Divide by 2 gives me 64. 64 is right in between 62 and 66, so I like it. Nice. Last one is the mode. Now the mode is just which one happens the most. So if we look at this, which one happens the most? Well, actually none of the numbers repeat. So there is no mode. Next one. Again, this is asking for mean, median, mode, so we're going to do the same process. The first thing we're going to do is mean, so I'm going to go ahead and pull up my calculator. And I'm going to clear this, and we're going to add it all up. 53 plus 50 plus 73 61 plus 68 plus 67. 7. Now I'm going to count to make sure I have them all. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I got all 8. Now I did notice I repeated that time, so they are going to have a mode. So now I'm going to type the 459 divided by 8. It says round to the nearest tenth. So I'm gonna round that so it's 57.4. Excellent. All right. The median means I have to put them in order, so I'm going to pull up my scratch paper. And I'm going to try to put them in order here. 47, 47, 50, 53, 60, 61, 68, and 73. 1, 2, 3, 4, 1, 2, 3, 4. All right, so I've got 8. So I'm going to look for the middle by having 8 on both sides. So it's between 53 and 60. So we're going to do this. We're going to add 53 and 60 and divide by 2 to find out what the middle of those two is. And if we do that, we get 113 divided by 2, which is just 56.5. Now, it gave me an ugly number in that it's a decimal, but that's okay. Last one is mode. It says which one happens the most. In this one, there is a repeat number. I can see it definitely when I'm writing them out in order. 47. Number 9. Oh boy, this is repetitive. Mean, median, mode here. This time they're decimals, but I'm going to go ahead and go for it. All right. I'm going to type in 0.8159 plus 0.8159 plus 0.8165 plus 0.8175 plus 0.7902 plus 0.8144 plus 0.821. I actually got, that was close. I was checking my math there and I noticed I had missed a decimal. So I did get an answer, but that is just those added up. That's not my mean. I need to take that number. And even though we're going to round it, I'm not going to round it yet. And how many are there? There's 1, 2, 3, 4, 5, 6, 7. Okay, that's a lot of decimals, but it says round to 5 decimal places. So I'm going to go ahead and type that in. So let's see. I'm going to go like this. All right. It is 0.81178. How many is that? Yeah, that's 5 decimal places, right? But 785, so I got to round up. 786, 8179. All right, I'm double checking because I get nervous when I have to round. Round to 5 decimal places. There's 5 numbers after that. I'm going to go for it. Oh, no. All right, so see if you can spot my error on that one. Oh, yeah, I see it. 159, and I did 159 again, but it's actually 159 and 195. Very close. All right, that's going to change this number. It'll be 56861. It's okay to get questions wrong. It totally is. All right, And then this one says round to 5 decimal places as needed. I actually, looks like I don't even need 5 decimal places. Sweet. So I'm going to go 0.8123. Yay! Now, if it says as needed, you don't need to add the extra 0 to make it a 5th decimal place. All right, the median. I like these better because I just have to put them in order. Although I still got to be careful, just like on that last one. I got to be careful that I split my sides here. So we got to be careful when we're putting in order that we're paying attention that we don't get them in the wrong order. So I'm gonna shorten this. I'm gonna do it a little bit quicker by just saying what is the middle number. It's, let's see, 0.8. I'm gonna put them vertical. 0.8121, and then I go, oh, you know what? 8144 comes after that. 0.8144. I'm kind of working backwards here, so 0.7902, 0.8165, or 8175, 0.8175, and then we also have 0.8165. We have 0.8195, and then we've also got right in here, we've got 0.8159. All right, that was annoying to write out, but we got it. And since there's 7 of them, there should be 3 on either side. So that middle number is our median. We don't need to figure out what's between 2 numbers because there's only one number in the middle. All right, which, if any of these weights, would be considered an outlier? So an outlier, remember, is a number that's way too high or way too low. And I'm tempted to say none of them because they're all pretty close. But if you look at them closely, all of them are 0.81 except for that one. 0.8121, 0.8144, 0.8165, 0.8175, 0.8195, 0.8159. So they all are really, really close. This one might be an outlier. So I'm going to go ahead and type it in. There's a formula for it, but I'm going to just type it in to see what happens. Let's see, it goes 0.7902. Yay. You see, that one just didn't fit. All the other ones matched. Find the mean with the outlier excluded. Oh boy. So what we need to do is we need to add up all the numbers except for that one. Okay. Now, the good thing is I've got my calculator. I didn't delete what I was working on before. So I can hopefully just go right in here and I'm going to erase that one. And I get a smaller number. But notice if we delete an outlier, we also need to, we've only got 6 numbers now. So I'm going to divide by 6 instead of by 7. 8, 9. Yeah, that looks, I mean, doesn't that look like it would fit right in the middle? Now, if you noticed, our original mean was actually on the very, very low end of our scale. So this one fits 0.815. Yeah, that seems perfect. So we're going to go ahead and type that in over here. The mean without the outlier is 0.8159. 8. And I don't need to round that up. That's 5 decimal places. Yay. Oh, it's asking me one last question. Find the median with the outlier excluded. So if I take out the outlier, my median is going to shift a little bit as well. So let's go back to where I wrote my numbers in order. All right, if I take that one out, I'm going to reorder these just a little bit. If I take that one out, and then I put them in order with 0.8144, and now I'm going to go ahead and put this guy in his place, 0.8159. Now what we see is that the median is going to be in between those two numbers. So guess what? We have to add those up and divide by 2. So if we add up 0.8159 and 0.8165, and we divide it by 2, we get 0.8162. Oh, I typed in the wrong place because I wasn't looking. Let's try this again. 0.8162. I'll close it. Oh, see, I'm just not typing it in right. There we go. 0.8162. Yay. All right, I'm going to do this one last one and be done. State the explanation whether mean, median, or mode gives the best description. The average height of women in this country. The average height of women gives the best distribution because I'm going to say mean, because it's probably symmetric with a single peak. Like there's, there's a lot of variation, but women are about the same size usually. I'm going to do one more just because that one was so quick. Consider 2 grocery stores at which the mean time in line is the same, but the variation is different. So in one store, you take the same amount of time on average, but sometimes you're in there really quick, and sometimes you have to wait a long time. So at which store would you expect customers to have more complaints about waiting time? I would say the one with more variation, right? Because if sometimes you get in and out really quick, and sometimes you have to wait a long time, it's going to be more frustrating in that one, as opposed to, I know there are some stores, if I go in, I'm going to have to wait in line, and I know it's always going to be about the same amount of wait, then I'm not really going to be frustrated about it. So I would say that the customers would have more complaints about the waiting time at the store that has more variation, because some customers are easily annoyed. That might not be the best answer. Customers would have, I think, more variation. So I'm going to check this last one. The customers would have more complaints about the waiting time at the store that has more variation, because some customers would have longer waits and might think they're being treated unequally because some people are getting out really quick. I'm going to like that one. All right, that is just the first 11 out of 44. These problems, many of them have several parts. They take time to work through, and you're going to make mistakes. You guys saw me make plenty. Some of them were judgment calls where I made the wrong call. Some of them were I just typed the wrong number in, okay? So watch out. Be careful, but don't get too frustrated if you get some problems wrong.